Okay, so yeah, these are just some diagrams I drew of the sun's orbit. This would be the path that the sun's orbit would trace from about 600 million years ago to 15 million years into the future, viewed from a vantage point directly above the galactic plane. So it kind of traces out this rosette pattern, what's called a rosette pattern, which is kind of like a precessing elliptical orbit. So the sun goes around on this elliptical orbit, and the ellipse also rotates at the same time. Yeah, so anyways, both the endpoints of this graph, here and here, are paragalacticon passages. So that's the closest approach to the galactic center. And apogalacticon represents the center of these globes. Okay. And this is all measured in kiloparsecs. And this next one is a view of the sun's orbit on the same time frame from a vantage point directly on edge with the galactic plane. So, okay, so if we take a look at this again, we can kind of approximate the sun's orbital motion with what's called the local standard of rest, which is kind of like a circular orbit approximation of the sun's orbit. So we can say that it kind of goes around in a circle roughly, but in addition to this, it also oscillates in the radial direction. So in this slide, this is actually this represents the galactic plane, and this is a diagram basically of the solar system's motion with respect to the local standard of rest. So we can see that it oscillates in the radial direction and the vertical direction at the same time. And this is a great diagram because it shows us all the points in the sun's orbit that we're interested in. We have paragalacticon here, apogalacticon here, galactic plane crossings here, and vertical maximums above and below the galactic. Okay, so now that that's done with, let's take another look at the data in a galactic context. So recall that the last galactic plane crossing was about 2 million years ago, and this was a period of time where there was significant cooling in the paleotemperature data, and the next previous galactic plane crossing occurred about 35 million years ago, and that's very close to this other area of significant cooling, where there was the development of the first ice sheets in the southern hemisphere. So when I first noticed this a few years ago, I thought it was a pretty good coincidence that you had the two previous galactic plane crossings corresponding with the two most prominent cooling events in the Sun zone. So, and they're within about 1 million years of the predicted, they're within about 1 million years of the galactic plane crossings, and the chances of that happening randomly are actually pretty slim. But what other markers can we look for in the geological record? What about the vertical maximums, which are going to occur roughly halfway between each of the galactic plane crossings? About 18.5 million years ago and 51.5 million years ago. Here we sort of see what might represent a local maximum of sorts, but it's not really that clear. It's, it's relatively close, but this one is pretty close to the Eocene thermal maximum. So it's almost dead on with where you see the local maximum. Okay. All right. Just let me check this. Okay, so also there's an overall cooling trend over the Cenozoic, and maybe that could represent the solar system's motion towards paragalacticon over at least the last 50 million years. Maybe there's a correlation there. And I really like that idea because if there is that sort of correlation, it represents a consistent correlation in the geological record. This here is a diagram of the gravitational potential of the Milky Way. in the plane of the galaxy. So it's like going further out from the galactic center, but always staying in the plane of the galaxy. So z equals 0. And the bounds of the sun's orbit and galactic potential are not here to give some kind of reference. Anyways, there seems to be a consistent correlation between going lower into the potential and towards lower temperatures. Lower in the potential would mean going to where there's more mass. So say when you go towards the galactic center, the density of stars increases. And same with going towards the galactic plane. So that represents the, Okay, anyways, there seems to be a consistent correlation between lower potential and lower temperatures and higher potential and high temperatures. Although there's not really they're not really sure what the mechanism is. It could be due to variations in density in the interstellar medium, effects on solar activity, and the Earth's ability to receive solar radiation. The idea that's really popular right now is related to cosmic rays. Some scientists say that cosmic rays could have an influence on cloud formation, so that could affect climate. And then the other idea that's been proposed just last semester is the idea of galactic tides, which is actually my idea, and it relates to the deformation of the solar system as a result of galactic tidal influence. And I really like this idea because when I plotted the varying local galactic tidal field strength using this model of the sun's orbit, it makes a pretty good correlation with the data.
We're over time, so just finish up.
Yeah, okay. Everybody get good with this? Okay, yes. Okay, so, anyways, I thought the data fit the model fit the data pretty well for the Cenozoic era, but I thought maybe I could look further back into the record to see if the correlations are there. And so I plotted data from Jan Visor's online database. And I also plotted on here the times of the galactic plane crossings with an X and vertical maximums with an O. So this is where you might expect to see local minimums and local maximums in the temperature graph. And for the first 3 galactic plane crossings and vertical maximums here, they fit the data pretty well. But after about 100 million years, gaps in the data start to exist, and it's harder to tell. But ultimately, I'm just going to leave it up to you to decide whether there's a correlation or not. Okay.
Now, unfortunately, we don't have time for questions, but if you have questions afterwards, I suggest going and chatting with Steve about it. It's a really neat topic.
Yeah, I really love talking about it. And I got one more picture for it. And if you have any comments or questions, you can email them to cosmoclimate with a C and Z at hotmail.com.